Okay, this video is talking about how to use a physical geoboard. This is a geoboard. This is one of the types of geoboards. And I think a lot of people think of these as devices that are used to teach geometry, and they're really good at that, but that's not their only purpose. In fact, I'm going to talk about how to teach fractions using geoboards. So let's say that I start out, like I always do, defining the whole. And I want to be able to have kids say, oh, this is one whole. One of the biggest purposes, let's see, 1, 2, 3, 4, 5, 6 squares. So I am going to label this as one whole. If you're trying to develop academic discourse with students in mathematics, really huge important part of it is getting them to label everything. So if that's one whole, now this is something that we've done a lot of. Developing in different, using different manipulatives. But if that's one whole, then I want to be able to define this little piece right here, and I'd say this little piece has to be 1/6. Now we want students to be able to say it's 1/6 because there's 1, 2, 3, 4, 5, 6 equal pieces make up one whole. And I want them to write that. So this piece right here is 1/6 because 6 equal parts make up a whole. That's important. And if they don't write it, if they don't say it, they're not learning it. I use the 1/6 as an important stepping stone to understanding this piece. This is a piece I think that a lot of kids, a lot of people have trouble with. Like, what would this piece be in value, like in fractional value? So let's put it on there, and I would say that that piece would have to be 1/12, but I want to have some reasoning for that. Why? Because there's, now if we look at these as up here, each one of these squares can be broken into 2 halves. This is like a half of the square, so it's 2, 4, 6, 8, 10, 12. So that's 1/12, and I want to say it's 1/12 because there's 12 equal parts that make the whole. Remember, these sentences that they write and say are super important. So what we want to have students say is, this is one whole, this is 1/6 because there's 6 equal parts that make up the whole this size, and this is 1/12 because there's 12 equal parts that make up the whole that size. Alright, now with the sample problem that we've been doing a lot of, that would mean that this piece right here has to be equal to 1/3. Again, why is it 1/3? Because 3 equal parts make up one whole. Can't tell you how important it is to say that over and over again, and to give students many opportunities to say it. That's why we're going to do, we're going to create fractions using many different types of tools. The harder one, I think a harder one, is what size, or what is the value of this size piece. Now, here, let me, sorry. When you create, this is harder. What is the value of that size piece? That size piece is harder, and so to look at what it looks like, we'll have to take a look at the whole here, and I'm going to relabel my whole over here. So this is equal to one whole. And let's say we have to have this piece right here. So there's a piece, here's another piece, here's another piece, and here's another piece. So we have this piece right here, this piece right here, this piece, and this piece over here. And all of those are that size right there. What I mean by that size is, look, it has a 12th right there, and then it has 2/12 in here. So what you might be thinking of is it has 3 of the small triangles, these unit triangles here. And look at this, each of these has 3 of the unit triangles, and there's 1, 2, 3, 4 of those. So this is 1/4. So this is equal to 1/4. Again, we want students to write and to say it's 1/4 because there's 4 equal pieces to make up the whole. I think what teachers should do here is get students thinking about unit fractions. For example, I chose the 1/6 to help me understand the 1/12. 1/6 was easy because there's 6 boxes that make up my whole, but the 1/12 wasn't as easy. But if I think of it as half of the box, then there's twice as many boxes, so that's 1/12. Now I've got this unit fraction that I can use to evaluate or analyze each of these pieces. So 1/3 becomes, well, that's 4 boxes. 4 triangles. So that's 4/12. Again, we want to train students to say 4/12 has the same value as 1/3, or 4/12 is an equivalent fraction to 1/3. And 1/4 is equal to 3/12. And now it's easy to add 1/3 and 1/4 because it's 3/12 and 4/12. All right. This is just an introduction to how we might use a geoboard.